So, at this point, we've spent a lot of time discussing what environmental science is, why it's important to study it, and other related considerations for environmental decision making. For this last section of the chapter, we are going to be switching gears because we want to keep in mind that environmental science is, on a fundamental level, a science. Yes, it intersects with many social and political issues, but at its core, it's a science. So, what does that mean? There are many definitions of science, but the essence of those definitions is that science is a specific process of gaining knowledge about the natural world. That process involves gathering evidence, meaning real world information, facts and data, and then using sound reasoning to come to logical conclusions based on that evidence. It is also helpful to look at the definition of science not only from the perspective of how it does operate, but also what kinds of things are not part of the operations of science. One of those is opinions or feelings, meaning judgments or viewpoints that are not based on evidence. For example, if your favorite color is green, there's not really evidence to support that. It's just how you feel. If pizza is your favorite food, again, that's a personal opinion. Another thing that science does not concern itself with is supernatural or paranormal matters, which are by definition matters related to concepts that are separate from the observable natural world. Given that science looks at observable, verifiable facts and evidence, and supernatural things are by definition not part of the natural, observable world, science does not study these things. Things like ghosts, for example. Science is interested in phenomena that are observable, detectable, things for which there is verifiable evidence. And despite what you may have seen on TV shows like Ghost Hunters, these supernatural things do not fall into that category. When it comes to actually doing science, there is a defined set of steps that are collectively referred to as the scientific method, which we will look at shortly. Before doing so, it's important to lay down some terminology that is significant in the sciences and make sure we understand what those terms mean. One important component of scientific inquiry is a hypothesis. A hypothesis is a proposed explanation of a natural phenomenon that can be tested through experiments. A theory is an explanation of a natural phenomenon that has shown to be true across many tests and is widely accepted as fact. This can be a little confusing sometimes because the way that we use the word theory in everyday language is different from what it means in science. In everyday language, we use the word theory as if it has the same meaning as a hypothesis or a hunch. So maybe you might say, I have a theory that my coworker Julie is the one who ate my lunch out of the fridge. That's not how the word theory is used in science. In science, it is the equivalent of a fact, the most certain knowledge that we can possibly achieve. And getting a piece of knowledge from hypothesis status to theory status takes decades, if not hundreds of years. Efforts of many, many researchers and countless studies that over and over again demonstrates that this knowledge is true. A final related concept is that of a scientific law. Again, the meaning here is different from the colloquial meaning because this law has nothing to do with the legal system. Instead, a scientific law is a mathematical formula that describes how components of nature will behave under specific conditions. For example, gravity is a scientific law. We know that objects are attracted to other objects with a force that is proportional to the mass of those objects. However, laws do not offer explanations of why these phenomena exist. The law of gravity does not explain why gravity exists. For example, just with mathematical relationship of gravity is. So we have established that science is a process of learning about the natural world that relies on collecting evidence and using logical reasoning to come to conclusions about that evidence. But what does that logical reasoning look like? Well, it depends on what type of approach is being used to study a phenomenon and what your goals are. A descriptive approach to a scientific topic aims to observe, explore, and discover the goals. The goal is to be able to describe a phenomenon. For example, a question that might be addressed with a descriptive approach in environmental science is, what is the rate of deforestation in the Congo over the past decade? In these situations, scientists use inductive reasoning. a form of logical thinking where observations are compiled to arrive at a logical conclusion. In reference to that example question, these observations would involve looking at how much forested area is lost in satellite imagery over the time period in question, and then performing calculations to figure out how that compares to the total forested area, thus arriving at a conclusion. Descriptive science is only one approach, though, and not all questions are suitable um, to this approach. Scientists can also take a hypothesis based approach. In these situations, you start with a specific question or problem, as well as a hypothesis that represents a potential explanation. Then you put the best that explanation to the test. This is called deductive reasoning. For example, one might start with a hypothesis that fertilizer runoff from poorly managed coastal cropland is harming coral reefs. To answer this, you might collect samples of coral and test them in a controlled laboratory setting where you add fertilizer to their environment, and then observe the results. In this case, the explanation comes first, followed by the observations, whereas in the case of inductive reasoning, you start with no explanation, collect the observations first, and then put together a conclusive explanation. Both of these types of logical reasoning are perfectly sound and used in environmental science, but they suit different situations.